the quadratic formula. The quadratic formula is used to solve quadratic equations, things in the form ax squared plus bx plus c equal to 0. And we've previously talked about how to solve quadratic equations using factoring and square roots. However, it may not work with those methods. It may be that my given quadratic equation is not factorable. We can't actually factor it, and we can't write it as square equal to some value. So the quadratic formula lets us solve the rest of the quadratic equations, things that don't satisfy those particular requirements. In order to solve these, we're going to use my quadratic formula. This says x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's look at how to use this. Let's look at the quadratic equation 8x squared minus 6x minus 5 equal to 0. In this case, a is equal to 8, b is equal to negative 6, and c is equal to negative 5. The quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So in this case, we have negative 6, which is positive 6, plus or minus the square root of negative 6 squared times 4 times 8 times negative 5, all over 2 times 8. As I simplify this, 6 squared is 36. Negative 4 times 8 times negative 5 is 160, and 2 times 8 is 16. So this is 6 plus or minus the square root of 196 over 16. If I move this up, the square root of 196 is 14. So I have two possible values. X is equal to 6 plus 14 over 16. And x is equal to 6 minus 14 over 16. 6 plus 14 is 20, so this is 20 over 16, which we can reduce to 5 over 4. For the second one, 6 minus 14 is negative 8. And negative 8 over 16 reduces to minus 1/2. So my two solutions are 5/4 and minus 1/2. The fact that we had this perfect square underneath the square root, the fact that we could actually take that square root, tells me that I've actually could have factored this particular quadratic equation instead of using my quadratic formula. However, this is a problem that tends to be more difficult for people to factor, so we can default to the quadratic formula if we want. Next, let's look at x squared plus 6x plus 3 equal to 0. In this case, I have a is equal to 1, b is equal to 6, and c is equal to 3. My quadratic formula says negative b, so minus 6, plus or minus the square root of b squared, or 6 squared, minus 4 times a times c, that would be 4 times 1 times 3, all over 2 times a, which is 1. So this is negative 6 plus or minus the square root of 36 minus 12 over 2. 36 minus 12 is 24. So we have negative 6 plus or minus the square root of 24 over 2. I can rewrite this. 24 I'm going to rewrite as 4 times 6. The square root of 4 is 2. We don't know the square root of 6. So I can write this as negative 6 over 2 plus or minus 2 square root of 6 over 2. Or in other words, negative 3 plus or minus the square root of 6. So my two solutions are negative 3 plus the square root of 6 and negative 3 minus the square root of 6. Now let's look at x squared minus 5x plus 7. In this case, a is 1, b is negative 5, and c is 7. My quadratic formula says negative b, that makes this a positive 5, is plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. So this is 5 plus or minus the square root of 25 minus 28 over 2. Or 5 plus or minus the square root of negative 3 over 2. Since this is a negative, I can rewrite this as 5 plus or minus I square root of 3 over 2, and I have my solution. If you want, you can rewrite it as 5 over 2 plus or minus square root of 3 over 2 times I.